All right, hello folks. We are on example 3. This is 6-1. And we're going to get through a few of these examples today, but I have a chart for you that you will need. So one side says positive z-scores, okay? One side says negative z-scores. I will get everybody a laminated copy of this. If Madeline, if you're watching this, I think Amber has them printed for you, but I will send a laminated one with her to give to you that you can replace it with, just so that you have one that's laminated, okay? So we use these charts like really a lot, okay? So let's talk through, before we get to example 1, let's talk through the example that we were going over yesterday. And I'm going to put the bell curve over here. You do not have to write this down, just listen. How about that, okay? Yesterday we were talking about ACT scores, and we said like the average maybe was like a 20, I don't know. And then our standard deviation, let's say like 3. I make them really nice numbers. Typically your average and standard deviation are going to have a decimal on it, but I'm making this easy just for time's sake, okay? My average is in the middle, that is a 20. Then I add standard deviations from there. So if I add 1, this would be a 23, 26, 29, typically. Like we could keep going forever, right? But there's not going to be very, like if I keep going, it would be like 32. But the higher you go, the less frequent that becomes, right? Okay. If I go lower, this would be a 17. This would be a 14. This would be 11. I could keep going, right? Usually when I fill out a bell curve, I do 3 on either side and then I quit, right? Because the people that live over here are not going to be very frequent, and the people that live up here are not going to be very frequent. Does that make sense? According to the data that I have. Some of you guys are like, I got a 32. I'm off the chart. Well, I made this data up, so it might be actually different than that. Whatever, okay? So, all right, talking about z-scores. Yesterday we did z-scores, and if you got a 20 exactly on the ACT according to this data, what would your z-score be?
0.
You would have a 0 z-score because you are on average, right? If you scored a 23, what was your z-score?
1.
A positive 1. If you scored a 26,
2.
positive 2. Positive 3 if you scored a 29. What happens if you scored a 17?
Negative.
You would have a negative 1, and that just means you are negative 1 standard deviations below average, right? You are 1 standard deviation below. Here you are 2 standard deviations below. Here are 3 standard deviations below, okay? Now, take out, do you guys have this chart? This like bell curve chart that tells you percentage-wise? Do you guys have one of those?
No.
Okay, if you don't, I'll write it here, okay? You guys have a laminated copy maybe of one of these, and it says something like this, where it says 68% of your data lives between -1 and +1. Do you remember the percentage that lives between -2 and +2?
I also don't know that.
Okay, that's fine. I maybe took them back from you. I don't know.
95.
I'll get you a copy of these. But -2 +2, there's 95% of your data that lives within -2 +2. Okay? Now, let's talk about that for a second. 68%, 95%. We, in the last chapter, said anything that is less than 2 standard deviations is considered significant, right? Or anything that's greater than positive 2 is also significant, right? And we also base that off of the 5% rule, right? If it has less than a 5% chance of happening, it's considered to be a significant value. And the reason why 5% is equivalent to outside of the 2 standard deviation range is because if 95% lives here in the middle, 5% is those 2 regions together, right? Or in other words, 2.5% lives here and 2.5% lives here, right? That's how that works, okay? So if you scored above, let's say like a 26 according to this data, you are in the highest 2.5% of people who took the ACT. Now, again, I made this data up, so if that was you, it's probably a little bit higher than that, the cutoff mark, but whatever. If you scored lower than a 14, you are in the lowest 2.5% according to this data, right? Which I made up, which may not necessarily be true, right? But that's why in last chapter, 5% was significant values, same as anything that's above or below 2 standard deviations, right? That's how we got to that, okay? Now, here's the problem, and here's where this chart comes into play that has all the numbers, right? The positive, negative one. Is that what happens if I scored a, I don't know. Let's do this real quick. If I scored a 20%, if I scored a 20 on the ACT, what percent of people scored less than I did?
50%.
50%, right? What percent of people scored higher than me? 50%, okay? But what happens if I scored, like, let's say a 21 on the ACT, right? Let's say I'm here at a 21. How many people, what percent of people scored less than me? Slightly higher than 50%, right? I'm right above average, so there's more than 50% of people below me, but what is that percentage exactly? We don't know, right? That's where this chart comes into play, okay? Does that make sense? All right, do you know what the z-score would be if I had a 21?
It'd be 1/3.
1/3, right? So 20 is here, 23 is here, right? That's a third of the way over. So my z-score, we'll talk about how to find that exactly, would be 0.33 if I round it off, right? That would be my z-score. Questions about that, how I got that number, right? I am a third of the way to the next cutoff mark, which is 23 if I have a 21. So 0.33 is my z-score. Okay, we're going to do our first lookup on this chart. So I have a 0.33. Here's how you look up on the chart. Very important. Watch this. Here is my chart. You guys have a positive z-score. I want to be on the positive side because here is where the mean is. My z-score that I'm looking at is to the right of it. I am a positive z-score. If I was talking about having a z-score that was negative, I would use the negative side, in which case I'm to the left of average, right? So that's how you can tell which page you need to be on. All right, so here is what I want you to do. On this positive z-score, Chase, on this positive z-score, we're going to find a z-score of 0.33. So the first place I start is where z is, and I look up 0.3. He is right here. I can stop right after that one. But I want 0.33. So like this guy, if I would go over to this column, this would be 0.30. This guy would be 0.31. This guy is 0.32. Do you see how this chart works? This guy is 0.33, which is the number that I want. So this, the row gives me the first decimal place. The column gives me the second decimal place. So 0.33 is 0.6293. Do you see where I got that number? Find that on the chart. So what I have just found is that, what was that number again?
0.6293.
0.6293, which means 62, almost 63% of people are less than me if I scored a 21 on the ACT. Does that make sense? We can look up those values using this chart when they are not nice z-score values. Got it? Okay, so that's our first lookup. Let's go to the first example, which is example 3, and we're talking about a bone density test. So I'll summarize this for you. We have a gal who has a bone density level that has a z-score of 1.27. So basically, however they measure bone density, because they do this for women who are at risk of osteoporosis. Do you know what that is? Right? Like a lot of times when you have curvature of the spine, or if you have like a low bone density, you have to take like vitamins and supplements and stuff or whatever. So whatever the average was, this person had a bone density that was 1.27 standard deviations above the average. Okay? That's what her z-score represents. She is 1 above average, 1 plus above average. Okay? I want to know what percent of people have a bone density that is less than hers. Right? So like what percent of people are lower than her? The thing that I always think about is in relationship to average. If I'm talking about percent of people lower than me, is that going to be more than half of the people or less than half of the people? More than half. You can see that this shaded region is larger than half, right? So what I want to do is, are you going to be on the positive side or the negative side? 1.27 is a positive number. So go onto your chart. Positive side, we're looking at 1.27. I have my chart right here. Let me erase some stuff. 1.27. So go to the column first. You're going to go down to 1.2, which is right here. Do you find him? Yeah. Then go over to the 7 mark, which is this column right here. Okay? 1.27. 0.8980. Did you find him? Yeah. On the chart, 0.8980. Okay? 0.8980. They have it listed here as well. What does that mean?
You're 89% better than everyone else.
Yeah, 89% of the people, or almost 90% of the people, have a bone density lower than you, right? That's where you are. Okay, now let's flip the switch a little bit. Let's say that I want to know, okay, how many people have bones that are stronger than me, or have a bone density score that is bigger than me.
11.2.
You're close, 10.2 if you subtract, right? So 0.8980, if I subtract that from 100%, that means 10% of the people are higher than me, right? Now, the way that this works is your chart always reads left, okay? The way that this chart is set up, regardless of what number you are looking up in this chart, it will always tell you how many people are lower than you. Got it? Always lower than you. So if you ever want to know how many people are above you, don't stop when you look up this number in the chart. You're going to have to subtract that, right? Okay? So, and flip over to the back side on the negative side. Whoop. That's my send the Zoom link. Thank you. Okay? On the negative side, you see this chart where it says negative? These are my z-scores that are to the left of 0. Which way does that one read? To the left as well, right? Even if you're on the left side of the chart, it's everybody that's lower than you. So regardless of whether you're on the positive side of the chart or the negative side, it's always going to tell you who is lower than you are. Yes, sir.
So we display, these numbers here, that's the area?
Yes, but area is representing the probability or the percentage of people.
So when it asks for the area,
yes,
we would just put that number.
Yes,
in.
yes,
Okay.
yes. The area or the percentage. Yes, exactly. Okay. All right, now it's going to get a little bit trickier, but not really. Not too bad. Okay. Let's go to this one, example 4. I would really encourage you, if they don't already have a bell curve, to make one so that you can see what's happening. I always put 0 in the middle there and draw my bell curve. It doesn't have to be pretty. So in example 4, do that. It's saying using the same bone density test, find the probability that a randomly selected person has a result above a -1. Okay, so where does -1 as a z-score live? Where will -1 live on this chart? This way. He'll be right there. -1 lives there, right? Okay, so what I'm going to do is I want to find the probability, and the probability lives in here, right? But if I look -1 up on the chart, which I'm going to do, -1, I have to be on the negative side, okay? And -1, -1, 0.0, I'm going to go to the first column, which is also 0.0. So this guy tells me, this number tells me -1.00. You see how that works? The first column is 0.00. 0.1587, okay? But 0.1587 is going to tell me what? To the left of me, 0.1587. Like 15, almost 16% of people are lower than a -1. I want to know if they deem -1 to be considered a normal reading, how many people are getting a normal reading. They want to know how many people are above a -1, which is considered normal. If I subtract this from 100%, 0.8413, I think. Is that true? 0.8413. I don't care if you write it as 0.8413 or 84.13%. I don't care. Okay? They're asking for what percentage of people are normal above that. So you have to look up the chart, you have to look up below, then you have to subtract it from 100%. Got it? Clear as mud? Not too bad? Okay, we're going to do example 5 and then I'll let you have time to work. Okay, example 5 is talking about finding the area between two values. So this gets a little bit tricky, but not really. Okay, I'm going to draw my bell curve. And we are looking at values between -1 and -2.5. So slap 0 in there somewhere. Put your bell curve. -1 is down here. -2.5 is down here. And I want to know what percent of people are having a bone density score between those two values. Okay, let's just think for a minute. Is this going to be more than half, more than 50%, or less than 50%? Right? Less than 50%. My whole chart, like this side of the chart is not filled in, like that would be less than 50% of the chart, okay? So I have two numbers here, and what we can do is look up -1 on the chart, which we've already done in the last example. What was -1 at? 0.1587. Okay? That's what a -1 was at, all right? But then if I look up -2.5 on the chart, let's go find -2.5. -2.5 is right here, and I want to go over to 0, so -2.50. Those are how many people are below a -2.50. 0.0062. That's less than 1%. 0.0062. Okay, that is a very small number. There are less than 1% of people that have a z-score less than 2.5, negative 2.5, okay? How do I figure out what percent of people live here in the middle? Yeah, all you have to do is subtract. 0.1587 minus 0.0062 is 0.1525, or 15.25% of people are going to have a score between those two values, roughly, right? Roughly 15.25%. Do you see how this works? Okay, good? Okay, I am going to stop there, and I'm going to give you some things to do. We'll pick up and do the rest of it tomorrow. We'll finish this tomorrow. But here is the deal. Go to your homework assignment and skip over, Madeline, if you're looking at this, I think the next things to come are like intro to 6-1 z-scores, which is this bell curve, and the cookie sheet. Hold on to those for now, but we're going to go to this one that has a bunch of shaded bell curves on it, okay? So this is the paper that you guys have. We're going to do all of the first page, but I'm going to talk about number 4 really quick, okay? So I will do number 4 with you real quick, because this time on number 4, they don't give you z, they give you what the area of this guy is. So how do I find z if I'm given that thing? No. What?
0.1857 is 2.1.
I have to look up the chart backwards. So I'm going to say chart backward. Okay? I am looking at 0.9857 in this chart. I'm going to make you dizzy. I'm sorry. 0.9587. Are we going to be in the negative side or the positive side? If 98% of people are lower than me, am I bigger than average or lower than average? I'm going to be on the right side, right? Positive side. So I'm trying to figure out what the z-score is for 0.9857. So I'm looking in here what 0.9587 is.
2.19.
Okay, 9857 is right here. And if I go over 2.19, you are right. So the z-score will be 2.19. And we looked it up backwards on the chart. Do you see how this goes both ways? You said 19? The z-score is 2.19. Okay? Do you see how this works? That's not that bad. Okay? All right? Number 6, if you talk me through number 6, you cannot just get away with looking at 0.8729. Why not? The chart only reads to the left. 0.8729 is not to the left. So you got to figure that out and then find the z-score. Got it? Okay? This is just practicing using the chart. Good, good? All right, there you go. That is all that I have. What?
You got that page?
What page? Oh, this one? The homework assignment? I didn't give it to you? Okay, I'll give it to you. Okay, bye people watching this video.